Hi, welcome back to Technical Mathematics. In this lecture, we will discuss another set of multiple choice questions from the topic coordinate geometry. At first, we will discuss few previous year exam questions and then we will proceed with certain miscellaneous topics in coordinate geometry. So let's get started. So let's start with problem number 1. The equation of a straight line making an angle of 135 degree with positive direction of x-axis and cutting an intercept 5 on y-axis is. So we are asked to calculate equation of the straight line which makes an angle of theta equal to 135 degree with positive x-axis and has a y-intercept of 5. Y-intercept is 5. Okay, so here we have to make use of slope intercept form. Okay, that is y is equal to mx plus c. So y intercept is given, that is the value of c is given, it is given as 5. Okay, but we don't know what is value of the slope m. Okay, but angle is given as 135 degree. From that we can calculate the value of slope. Okay, the m value, slope value will be equal to tan theta. Okay, and theta is 135 degree, so m will be equal to tan 135 degree and tan 135 degree is minus 1. Okay, so equation of the line will be y equal to minus 1 into x, that is minus x plus 5. Okay, so here the right answer is given by option C, y equal to 5 minus x. Okay. Now let's move on to problem number 2. The x-intercept of the line passing through the point 1, 1 and perpendicular to the line x minus 2y plus 1 equal to 0 is. So we are asked to calculate the x-intercept of the line which passes through the point 1, 1 and perpendicular to the line x minus 2y plus 1 equal to 0. Okay, so to find out the x-intercept, at first we have to find out the equation of the line itself. Then in that equation, if we put y equal to 0, we will get the value of x-intercept. Okay, so at first let's try to find out the equation of the line. So here we are given one point x1 y1 equal to 1, 1. Okay, so we know one point on the line, but we don't know any other point or slope of the required line. Okay, but we are given equation of perpendicular to the line, so that is x minus 2y plus 1 equal to 0. So we may calculate the slope of the required line from the slope of this perpendicular. Okay, so we will make use of point slope form to find out the equation. Point slope form says y minus y1 is equal to m into x minus x1. So x1 y1 is a point on the line and m is the slope of the line. Okay, so let's take the required line slope as m2. Okay, we have a perpendicular to the line, its equation is x minus 2y plus 1 equal to 0. Okay, let's take slope of this line as m1. So what will be m1? m1 will be equal to minus of a by b. A represents coefficient of the x term and b represents coefficient of the y term. Okay, so m1 will be equal to minus of, here a value is 1, coefficient of x is 1, so a value is 1 divided by b value will be minus 2. Okay, coefficient of y term is minus 2, so therefore 1 divided by minus 2. Okay, so we have a minus sign here, so this minus and this minus will be getting cancelled. Effectively m1 value we will get it as 1 by 2. Okay, now for two lines to be perpendicular, the equation to be satisfied is that the product of the two slopes m1 into m2 should be equal to minus 1. Okay, so we have calculated one slope, it is 1 by 2, so we may equate that here. So 1 by 2 into m2 will be equal to minus 1. This implies that m2, the slope of the required line, will be equal to, okay, let's cross multiply, we will get m2 value as minus 2. Okay, so now we know one point on the line, that is 1 1, and also we know the slope of the line, that is slope is minus 2. Okay, so let's write down the equation using point slope form. Okay, so equation of the line will be y minus y1. So y1 is 1, so y minus 1 equal to m2. m2 is minus 2, so minus 2 into x minus x1. x1 value is 1, so x minus 1. So this is the equation of the line. So let's simplify this. What we get is y minus 1 equal to minus 2x plus 2. Okay, now in this equation we have to put y equal to 0. So put y equal to 0 in this equation. What we get on left hand side, we will get minus 1 equal to minus 2x plus 2. Okay, now let's take this 2 to the left hand side, we will get minus 3 equal to minus 2x. Okay, now let's omit these minus signs on left hand side and right hand side. So x value, we will get it as 3 by 2. Okay, so the value of x-intercept will be 3 by 2. So that is given by option C here. So option C is the right answer. Okay, let's move on to problem number 3. The equation of the straight line that has x-intercept minus 3 and is perpendicular to the line 3x plus 5y equal to 4 is. So we are asked to calculate equation of the straight line that has an intercept of minus 3 and is perpendicular to the line 3x plus 5y equal to 4. So we are given the x-intercept. It means that we can calculate one point on the line. One point on the line will be minus 3 comma 0. Okay, the line will be passing through this point on the x-axis. Okay, minus 3 comma 0, because x-intercept value is minus 3. So since it is a point on the x-axis, the y value, the y coordinate will be 0. So line will be passing through the point minus 3 0. Okay, now it is given that the line is having a perpendicular which is given by 3x plus 5y equal to 4. Okay, so perpendicular to the line is 3x plus 5y equal to 4. Okay, so let's calculate slope of this line. Okay, we will take the slope as m1. m1 will be equal to minus 3 by 5. Okay, minus of x coefficient of x term divided by coefficient of y term. So we will get slope value as minus 3 by 5. Okay, now since this line is perpendicular to the required line, the slope of the required line, let it be m2, let m2 be the slope of the required line. Okay, so slope of the required line must satisfy the condition that m1 into m2 is equal to minus 1. Okay, so m1 is slope of the perpendicular to the required line, so m1 into m2 will be equal to minus 1. Okay, so from this we can calculate the value of m2. m2 will be equal to minus 1 divided by m1. Okay, m1 value we are getting it as minus 3 by 5, so m2 will be equal to minus 1 divided by minus 3 by 5. Okay, so effectively we will get the m2 value as 5 by 3. Okay, now let's try to write the equation of the straight line using point slope form. Okay, point slope form says that y minus y1 is equal to m into x minus x1. Okay, so in this case, okay, y1 value we may take it as 0. Okay, because we will take this point as one point on the line. Okay, we will take this point as x1 y1. Okay, so y1 value is 0, so we can substitute that here, y minus 0 equal to m value. Okay, it is calculated, we have calculated it as 5 by 3, so 5 by 3 into x minus x1. x1 value we will take it as minus 3, so x minus minus 3. Okay, let's simplify this. Left hand side will be y equal to 5 by 3 into x plus 3. Okay, now let's cross multiply. What we get is 3y is equal to 5x plus 15. Okay, so we will get the equation of the line as 5x minus 3y plus 15 equal to 0. Okay, so this answer is given by option B here. Okay, option B is the right answer. Okay, now next one is problem number 4. The distance of the point alpha comma beta from the origin is. So we are asked to calculate the distance of one point from the origin. So we know that if we have 2 points on the xy plane, let one point be x1 y1 and let another point be x2 y2, the distance between these 2 points can be calculated as d equal to root over x2 minus x1 whole square plus y2 minus y1 whole square. So this is the equation what we use to calculate distance between 2 points on the xy plane. Okay, so distance is taken as d here. Okay, so d is given by the equation root over x2 minus x1 whole square plus y2 minus y1 whole square. Now here we are asked to calculate distance of the point alpha beta from the origin. So one point in this case is alpha beta and the other point is origin, that is 0 0. Okay, so we are asked to calculate the distance of the point alpha beta from the origin, that is 0 0. So if we equate these values in here, what we get is d equal to root over alpha minus 0 whole square, so that is alpha square plus beta minus 0 whole square, so that is beta square. Okay, so we will get the equation of the distances d equal to root over alpha square plus beta square. Okay, so that is given by option D here. Okay, so option D is the right answer. Okay, now let's see problem number 5. The coordinates of the centroid of a triangle whose vertices are 0 6, 8 12 and 8 0 is. We are asked to calculate coordinates of the centroid of the triangle with vertices 0 6, 8 12 and 8 0. Okay, so let's see what is centroid of a triangle. Centroid is one point at the middle of the triangle where the medians meet. Okay, a triangle will have 3 medians. Median is a line drawn from center of one side to the opposite vertex. Okay, so a triangle will have 3 vertices and it will have 3 medians. Okay, 3 vertices and 3 medians. Okay, so median is drawn from center of one side to the opposite vertex. Okay, so let the coordinates of the vertices be x1 y1, x2 y2 and x3 y3. So in that case, coordinate of this point, that is centroid, will be nothing but x1 plus x2 plus x3 divided by 3, and y coordinate will be y1 plus y2 plus y3 divided by 3. Okay, so let's make use of this equation to calculate centroid of the triangle given in this problem. Okay, so vertices are 0 6, 8 12 and 8 0. So centroid, coordinates of the centroid will be, the x coordinate will be 0 plus 8 plus 8 divided by 3. So that will be the x coordinate. So it is equal to 8 plus 8, 16 divided by 3. Okay, x coordinate value will be 16 divided by 3. Now let's see what is y coordinate value. Y coordinate value will be 6 plus 12 plus 0 divided by 3. So that will be equal to 6 plus 12, that is 18 divided by 3. So we will get the value as 6. So the coordinate of the centroid will be 16 by 3 comma 6. Okay, and that is given by option D here. Okay, so please remember this formula. It's very simple. If we know coordinates of the three vertices of a triangle, then coordinate of the centroid will be nothing but x1 plus x2 plus x3 divided by 3 comma y1 plus y2 plus y3 divided by 3. Okay, so where x1 y1, x2 y2 and x3 y3 are coordinates of the three vertices. Okay, now let's see problem number 6. Area of the triangle whose vertices are 1, 2, minus 2, 3 and minus 3, minus 4 is. We are asked to calculate area of the triangle. Okay, coordinates of vertices are given and we are asked to calculate area of the triangle. So in order to calculate area of the triangle, we can make use of this formula. If coordinates are known to us, area can be calculated like this. Area of the triangle will be equal to 1 by 2 into x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2. So it is easy to remember because here the first one is x1 followed by y2 followed by y3. Okay, so 1, 2, 3, that sequence comes here. Then if you take the second term, what we have here is x2 into y3 minus y1. So 2 followed by 3, 3 followed by 1. Okay, plus the third term is x3 into y1 minus y2. Here again you can see that 3 followed by 1, 1 followed by 2. Okay, so the terms outside the bracket is x terms and which are inside are y terms. Okay, or y coordinates. Okay, so x coordinates are outside the bracket and here inside the bracket we are having difference of successive y coordinates. Okay, so x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2. Okay, so that into 1 by 2. So this will be the area of the triangle with coordinates x1 y1, x2 y2 and x3 y3. Okay, so let's make use of this formula to calculate the area in this problem. Okay, so area of the triangle will be equal to half of x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2. Okay, so let's equate the values. So 1 by 2 into x1 is 1, so 1 into y2 minus y3, y2 is 3, so 3 minus y3 value is minus 4, so 3 minus minus 4 plus x2 is minus 2, so minus 2 into y3 minus y1, y3 value is minus 4, so minus 4 minus y1 is 2, so minus 4 minus 2 plus x3 is minus 3, so minus 3 into y1 minus y1 is 2 minus y2 value is 3, so 2 minus 3. Okay, so let's calculate the area. Half into 3 minus minus 4, that is 3 plus 4, so we will get it as 7 plus, here we have minus 2 into minus 4 minus 2, minus 4 minus 2 is minus 6, minus 6 into minus 2, so we will get it as plus 12. Okay, then plus, here we have minus 3, here we have 2 minus 3, so 2 minus 3 it is minus 1 into minus 3, so we will get it as plus 3. Okay, so we will get the value as 1 by 2 into 7 plus 12 plus 3, so 7 plus 12 19 plus 3, that is 22 divided by 2, we will get the answer as 11. So area of the triangle will be 11. Okay, and that is given by option B here. So option B is the right answer. Okay, so please remember this formula. If we know the coordinates of vertices of a triangle, we can calculate the area of the triangle by using this formula. Okay. Now let's see problem number 7. The points A, B and C are collinear if the value of P is. So we are given 3 points which are collinear and we are asked to calculate the value of the unknown value, that is P. P is the y coordinate of point B. Okay, so before proceeding with this problem, let's see what is collinearity. Okay, 3 or more points are said to be collinear if they all lie on the same straight line. So if the points are lying on the same straight line, then they are said to be collinear. Okay, now let's see how to check the collinearity. So if we are having 3 points, we will take one point as a common point, okay, such that we will get 2 segments. Okay, so here the first segment is nothing but the segment AB and the second segment is nothing but segment BC. So if the slope of the segment AB is equal to slope of the segment BC, then the 3 points are said to be collinear. Okay, so here the condition is that the slopes must be equal with one point as common point. Okay, so here B is taken as the common point. Okay, so with B as common point, if we are getting slopes of segment AB and segment BC equal, then the 3 points will be collinear. Okay, so in some cases we won't be able to identify the common point. So in such cases what we can do is to check the collinearity, we may find out the area of the triangle formed by the 3 points. Okay, if the 3 points are lying on a straight line, then it is not possible to create a triangle with the 3 points as vertices. Okay, so if A, B and C are lying on the same line, then it is not possible to create a triangle with A, B and C as vertices. Okay, so in such cases, if we find the area of the triangle with A, B and C as vertices, then you will get the value as 0. Okay, so to check whether the given 3 points are collinear or not, we may calculate the area of the triangle formed by those 3 points, and if the area is found to be 0, then it means that the 3 points are collinear. Okay, now let's go back to our problem. So the 3 points are minus 5, 1, 1, comma P and 4, minus 2. Let's try to find out the area of the triangle formed by these 3 points. Okay, so it is equal to half of x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2. Okay, so this value should be equal to 0. Okay, because it is given that the 3 points are collinear. Okay, so let's substitute the values. It's okay, it implies half of x1 is minus 5, so minus 5 into y2 minus y3. Y2 is P, so P minus y3 is minus 2, so P minus minus 2, so we will get it as P plus 2. Okay, plus x2 is 1, so 1 into y3 minus y1. Y3 is minus 2, y1 is 1, so minus 2 minus 1, so we will get it as minus 3 here, plus x3 is 4, so 4 into y1 minus y2. Y1 is 1, y2 is P, so 1 minus P. Okay, so this must be equal to 0. Okay, so this 2, when you cross multiply, you will get 1 here. So let's rewrite this one as the term what we have in the bracket must be equal to 0. Okay, so minus 5p minus 10 minus 3 plus 4 minus 4p should be equal to 0. Okay, let's combine p terms. Here we have minus 5p, here we have minus 4p. So when you combine those two, we will get minus 9p. Then here we have minus 10, minus 3, minus 13 plus 4. So we will get it as minus 9 equal to 0. So this implies that minus 9p equal to 9. So this implies that p value is minus 1. So p equal to minus 1. That is the right answer. So that is given by option C here. So option C is the right answer. Okay. So 3 points are collinear if they lie on the same straight line. Okay. So to check whether the given points are collinear or not, we may calculate the area of the triangle formed by those 3 points, and if the area is 0, then we may say that those 3 points are collinear. Okay, so with this we are coming to end of lecture 18. In lecture 19 we will start calculus. In lecture 19 we will discuss limit of a function. Okay, so see you in lecture 19. Goodbye.